All right, welcome. Thanks for joining section 2.7, getting some optional slides out of the way, just 3 of them, quick, hopefully. Sometimes these questions take a little bit longer though. So let's get right into it. We're gonna start by drawing those graphs, and just to be wonderful, I'm gonna go and draw that, or those axes on all those questions, and then I'm gonna go back to the beginning. Okay, so I hope you followed along with that. Now, first thing I'm supposed to do is simplify this. If I factor the denominator here, I get x plus 3 times x minus 3. And nothing's going to cancel off there, which is perfectly fine. That means I can just go straight into the, the nitty-gritty of the graphing. So the y-intercept, if I take f of 0, in the numerator I get 0. In the denominator I get -9, which is just 0. So 0, 0 is going to be one of the points on this graph. Next, I talk about the vertical asymptotes. Vertical asymptotes, I look at when the denominator is equal to 0. That's going to happen at 2 different times, x equals -3 and x equals +3. So I go to -3, draw my vertical asymptote. I go to +3, draw my vertical asymptote. Next, my horizontal asymptote. Horizontal asymptote is when I look at the degree on top and bottom. The degree on the bottom here is larger, which means it's automatically y equals 0. Next, I look at the zeros. Zeros, I look at the numerator and when that's equal to 0, which only happens at one spot here, x equals 0. And if I go to graph that, that was the same as the y-intercept. So I've got all my asymptotes and zeros and y-intercepts set up. So the next thing I have to do is do some sign analysis, sort of. So over here, I'm going to look at 4 and I'm going to look at 2. I'm going to look at the 2 things that are next to the asymptote so that I can see where exactly am I function-wise for both of these. I'm also going to look at -2 and -4 so that I can see where am I on both sides of this asymptote. So I'll make, a little xy table or x and f of x table. And I'm going to substitute in -4, -2, +2, and +4. Substituting -4 into this, I get -8 over -4 squared is 16 minus 9 is 7, so -8/7. Now, I don't actually care where -8/7 is, it's a little bit more than 1, cool. But what really is important is just that it's below this asymptote, so it's somewhere down here. Sorry, 4, I covered you up. Next, -2. If I substitute -2 into this, I get -4 over -2 squared, is 4, minus 9 is -5. So this is +4/5. Again, so a little bit shy of 1, but I'm really just concerned with the fact that it's above this asymptote. Then I substitute in +2. 2 times 2 is 4. Over 2 squared is 4, minus 9 is -5. So I have -4/5 now, which means now I'm down here. Sorry, that's not 2. I'm down here for 2. Sorry, 2, I covered you up again. And then 4, if I substitute 4 in, I get 8 over 4 squared minus 9 is going to give me 7, so +8/7. Based off of just these points, I can graph this function. In this top right corner, I have to be bounded by these asymptotes. In this bottom left corner, I have to be bounded by these asymptotes. And in the middle of this, sort of a weird case, I have to be bounded by these asymptotes, but I can still go through this point. So the way that this looks is just like this little cubic function happening inside here. That's why it's important to pick both something to the left of this asymptote and to the right of this asymptote, because what happens inside here can look different. So you have to make sure you're picking one to the right of this, one to the left of this. All right, moving into our next example. First thing we want to do is simplify if possible. It's not possible to simplify this one. So the first thing I'm going to do is the y-intercept, f of 0. That's going to give me negative 3 over 4. So that's just, a little bit less, or a quarter less than negative 1. Then I look at my vertical asymptote. Vertical asymptote is when the denominator is equal to 0, which is going to be at negative 4. So I go to negative 4, and I draw that dashed line. Horizontal asymptote. Horizontal asymptote, because the degrees of these are the same, you look at the ratio of the coefficients. So this will be y equals 4. So 1, 2, 3, 4, and there's my horizontal asymptote. Next, my zeros. Zeros, I'm looking at the numerator and setting that equal to 0. So I'll get x equals 3/4. So at positive 3/4, I have my x-intercept. Now, because I know these 2 points have to be part of my rational function, I do know that my rational function looks like this. Again, bounded by those asymptotes. And if I wanted to just quickly substitute in, I would pick something like negative 5. When I substitute negative 5 into this, I get negative 20 minus 3, which is negative 23, over negative 5 plus 4, which is going to give me negative 1. So this is positive 23. In this particular case, I am concerned with this number, not the sign of it, because I'm trying to see whether or not this is higher than 4. So if I had gotten something like 2, that would mean that I'd be sketching this rational function down here. Because I got something like 23, that's super high up here. It's way up here. So I've just got this rational function bounded by these asymptotes. Make sure that you're not crossing over those asymptotes when you're drawing these rational functions. This one's a little bit of a tricky one just because it goes so high. So the sketching of it is a little bit tougher or weirder. But you'll usually have questions that, sort of look like this, where it's easier to draw. All right, moving into our last example then. Sketch a graph of 2x plus 4 over x squared plus 6x plus 8. First thing that we're going to do is factor. So this is 2 times x plus 2 over x plus 2, x plus 4. Our x plus 2's cancel, and what this tells us, again, if we remember, is a hole happens in the graph. So we'll sort of just keep that in mind as we go on throughout this. First, f of 0. By the way, sorry, we're using 2 over x plus 4. So we can find everything using this. So if I substitute 0 into this, I get 2/4, which is 1/2. So I know 0, 1/2 is my y-intercept. Vertical asymptote. I'm looking at when this denominator is equal to 0, which would be x equals negative 4. So we go to negative 4. We draw that vertical asymptote. Horizontal asymptote. The degree on the bottom is 1. The degree on the top is 0, since there is no x there. When the bottom is larger, it's y equals 0. Next, we look at the zeros. Zeros happen when the numerator is equal to 0. Well, there's no x in the numerator, so we have something like 2 equals 0, which is never true. So there are no zeros here. The other thing you may want to keep in mind, or well, you should keep in mind, is the domain. X cannot be negative 4, because that's, this vertical asymptote. But x can also not be negative 2, because of that hole in the graph. Now, I need to figure out where this function is, so I'm going to substitute into a table negative 3 and negative 5. When you're substituting those in, you can substitute them into the simplified function. This function and this function are the same everywhere other than at negative 2, they are different. That's something that you sort of developed when you were looking at tables in section 2.6. So negative 3, if I substitute that into this, I'd get 2 over 1, which is 2. So negative 3, 2. -5, if I substitute into this, I get 2 over -1, so -2. That tells me where my function is. At -2, I have to keep in mind that I have a hole in this graph. So as I'm making this portion, when I get to -2, I draw a hole and then continue. Over here, no domain issues, so I just draw my rational function. That hole is very important. It's your graphical way of saying this one exact little point does not actually work for the original function. All right, you can get started on some of that 2.7 homework. As you can sort of realize with these questions, as long as you know how to do section 2.6, the 2.7 portion of it, not very difficult. We're just graphing all of that information that you just found.